quick introduction of our first speaker, Dominik Halbeisen. He's a solutions expert for technical industry at GS1 Switzerland. And Dominik has been with us. He's got significant experience in rail. So he's been with us since his days, or cooperating with OriginTrail since his days in SBB Swiss Railways, and he just recently moved into his new role at GS1. So we're very happy to continue our collaboration with him. And he's going to be talking about discoverability of physical assets with GS1 and OriginTrail. So Dominik, if you are online, I will hand over to you. The floor is yours.
Thank you very much, and thank you for the welcoming words. A very warm welcome to Ljubljana, and thank you very much for being able to present in slides what we have done together with OriginTrail over the last few years. So what brings me to you, the discovery service in rail? It's in short an object name service for vehicle visibility events. And I'm going to start with a few words about who GS1 is. GS1, as already mentioned, is the organization behind the beep, behind the barcode. And we at GS1 Switzerland are just one member organization out of roughly 150, so we cover the whole globe, and scan roughly 7 billion barcodes a day. What is one of our driving forces is that we are international and local, driven by our members. That's the defining line behind the slides I'm going to show to you. And we solve one issue that has been around for a very long time. Who in a private environment is the neutral party, the neutral network? And the slides to come turn around this notion of GS1 being a neutral intermediary, a neutral party, which can thereby solve problems that otherwise could not be addressed as easily. What is the starting point? In Ljubljana, you are along a European rail corridor leading to Trieste and Koper. And in Switzerland, we have the main challenge. We are on the orange rail corridor, which leads from the northern ports down to the south through the Alps. And recent weeks have shown that this is a very critical infrastructure and that we do not have in Europe a complete picture which involves all the parties that participate in this exchange of freights, goods, and services. That's the vehicle owners and holders. The ECM maintainers, a very technical term meaning the parties which maintain freight or generally rail vehicles. The railway undertakers, that's a technical term defined by the European Union, so not in the proper sense of the term, but those are the companies that actually operate railway operations, and last but not least, the infrastructure operators, so the rails on which the freight runs. Now, what has this got to do with a distributed knowledge graph, with a sharing of information? Very simple. Data sharing is absolutely relevant for safety reasons when we talk about European freight and or rail corridors, because they're crossing many countries, many legal systems. And being able to evaluate and share data cross-border is absolutely crucial. Why? Because if we do not know what happened 1,000 kilometers ago, accidents happen. Why do accidents happen? Because wayside monitoring information cannot be freely shared and available where it's required. What you see on the right-hand side is 2 months old. It's an accident in the world's longest tunnel. A rail car derailed because information that could have been obtained was not obtained, and a distributed knowledge graph could have been the answer and prevented this. So right now there is no rail link between Northern and Southern Europe through the Gotthard. There are other rail links open, but one major artery is cut, and the distributed knowledge graph could have been the answer to that. Why? Because infrastructure operators offer data, all in their own format, and the railway undertakers, again the technical term, meaning the operators, do not necessarily know who has all the data. And that's an issue. Why? We see on the right-hand side. So it is very difficult for the operators to create a complete picture or to create a normalized big data pool for the reasons mentioned above. The issue lies in the high number of parties and connection points. As shown before, the corridors traverse and cross different countries, different organizations, different companies involved. And data sharing at first looks easy because we just need to connect two parties. Party A1 using a system in green, party B1 using a system in orange. And then another party using the system in green can join, just establish another bilateral connection. So far, so easy. But what when a party with system pink joins C1 and starts connecting? The proposition becomes ever more complex because now we are not talking about one bilateral connection or a type of mapping connection, but already about three different possibilities. And the proposition starts to become ever more complex the more parties we try to involve. And you see where this is leading? Nowhere. This is the situation we are facing right now, or have been facing so far, in regards to the freight corridors in Europe. However, to gradually solve the issue, standards have been developed. On the one hand side, there is a GS1 standard out there defining how to identify rail vehicles. It's been out there for almost 10 years now, and it is based on the Global Individual Asset Identifier, in short, GIAI. You can see those identifications on most rail vehicles in Europe. It's a very small black RFID tag that you will see on the side of the vehicle. That's an SBB locomotive, and that's a DBIC seen when entering or getting on board the train. And this GS1 standard has found its way into the European norms, EN 17230. But I'm not going to dive into the norm. That's just to make the point that what started with GS1 has now moved into a European norm. And we also developed a standard to exchange data in a standardized way across the rail industry using EPCIS, the European Product Code Information System. It's not about the product, but about the rail vehicle, but the ID is valid nonetheless. So with this in hand, it suddenly becomes possible to share data. And how? In connecting all the parties to a central repository. There can be different repositories that are again linked to each other, but the main ID remains. Instead of having a very complex end-to-end relationship, we create a one-to-end relationship and then can connect the different repositories with each other. Now an issue comes up. How do we find all the different repositories out there? How do we find all the different parties out there? That's been an unsolved challenge for years now. And what has been missing? An object name service, so to name it. That's the service that keeps the information where the information is stored. And our members, we are very much membership driven, being a not-for-profit organization, have been demanding this very urgently for the rail industry. We want to know where the information is stored. And so we have built something in that direction, but before we go there, just a very quick explanation. An object name service is in principle nothing else than a domain name service. It's a service that keeps the information where the information is, but it's not web pages, it's repositories. And it's kind of a Google, but without all the advertisement, as we are membership financed. So we are not going to create an IP 8888, a Google domain name server, but we have created an object name service. What does it look like? It's actually, I'm showing here a UI, but it's a proof of concept. And the most important characteristic is that it is based on privacy requirements by our membership community. We do not want to have an open name service, which allows everybody to query for data, but first you need to have password protected access. Why? Because knowing where a rail vehicle has gone is of safety critical importance. So you want to restrict this. Therefore, as you can see on the right-hand side, the access to the ONS service is restricted, password protected. The roles of who can access are defined by the European Union. So only the companies entitled to access this service have a password and username. And the data, again, is governed by the owner. So the ONS, as we all know, does not share the data. It just tells us where to look for the data. And the data access is, again, protected, authenticated by the parties collecting the data and holding the data. We are not alone in this undertaking. GS1 standards are based on open and public architecture, and other solution providers are building the same solutions. OriginTrail, as we are learning today, and as we are hearing today, is going the same direction. And the idea is to create a linkable ecosystem, which will prevent vendor lock-in. There will be no proprietary solutions. The idea is to create an ecosystem. We are driven in the rail sector, but the idea is not at all restricted to the rail sector. The idea is absolutely open. We can imagine an Internet of Things where there is a central or even distributed instance of where to look for the information, and that connects me to the parties holding that information. So with GS1 standards, the ecosystem stays open, innovation-driven, and scalable. It's not proprietary. To go back to the rail case, what is the goal? The goal is very simple. Whenever we have an event, the existence of the event is posted to ONS. And this allows parties that are interested in events to query for the whereabouts of those events and then connect, not via the ONS, but by directly contacting the repositories which hold the events to get access to them. And this will allow to connect different dots along the journey of a rail vehicle. Once a critical self-sustaining threshold is crossed, and this is why the rail case is so important, the architecture can support itself. The architecture is open and can, as already mentioned, support data sharing on all different types of objects. There is no limit as long as we identify, capture, and share information in a standardized way, as for instance with GS1 standards and as shown with the rail case. From there, the sky is the limit. Thank you very much.